In this lesson, we're going to explore how to solve quadratic equations, which are essential in algebra for finding values that make polynomial expressions equal to zero. Let's examine this specific quadratic equation, x squared plus 4x minus 7 equals 0. This is a perfect example to demonstrate the quadratic formula. Before we can solve this equation, we need to understand its structure. Every quadratic equation consists of specific terms that we need to identify. The first term is x squared. This is our quadratic term, and it's what makes this equation quadratic rather than linear. Any equation with an x squared term will have exactly two solutions, whether real or complex. Next, we have 4x, which is our linear term. The coefficient 4 affects how the parabola is positioned horizontally. A larger coefficient shifts the axis of symmetry further from the origin. Finally, we have -7, our constant term. This value determines where the parabola crosses the y-axis. Since our constant is negative, the parabola will cross the y-axis below the origin. To use the quadratic formula, we need to write our equation in the standard form, ax squared plus bx plus c equals 0. This standard form helps us identify the coefficients we'll need to substitute into the formula. In our equation, a equals 1, which is the coefficient of x squared. Although it's not written explicitly, when no number appears before x squared, the coefficient is understood to be 1. The value of b is 4, which is the coefficient of our linear term x. This middle term will affect both the position and the direction in which the parabola opens. And c equals -7, our constant term. The sign of this term is important because it tells us whether the parabola crosses the positive or negative side of the y-axis. So for our quadratic equation, x squared plus 4x minus 7 equals 0, we've identified that a equals 1, b equals 4, and c equals -7. These are the exact values we'll substitute into the quadratic formula to find our solutions. With these coefficients clearly identified, we're now ready to apply the quadratic formula. The formula will give us the exact values of x that make this equation equal to 0, which are the points where the corresponding parabola crosses the x-axis. In our previous work, we ended up with the quadratic equation x squared plus 4x minus 7 equals 0. Before solving this, we need to identify the coefficients that will plug into the quadratic formula. To identify these coefficients, we'll compare our specific equation with the standard form of a quadratic equation, ax squared plus bx plus c equals 0,